In last lecture, we can study water supply scheme, then importance parameter of the water supply scheme, then design period, then factor affecting the design period, then flow diagram of the design period, and flow diagram of the water supply scheme, then intake structure, then types of intake structure, then factor affecting the intake structure, and then types of pipe, then water convey system. In this lecture, we can study the quantity of water. So what is meant by quantity of water? So this is a next quantity of water. So introduction, the assessment of total quantity of water required for town or a city is the fundamental work in water supply scheme. The scheme should be designed to run efficiently for at least 3 future decades. So 1 decade means a 10-year. So depending on the total water demand, the suitable source of water should be find out. Sometimes one source may not be sufficient to water supply scheme throughout the year. In that case, other source should be find out. This is the introduction of the quantity of water. So this is this slide. It's additional information of the quantity of water. So it is not a part of syllabus. This is a information about availability of water. So this is a diagram. So next, from the total global water distribution from groundwater 0.75 of the total water on earth, and from lake 0.007% of the total water on the earth, from river 0.002% from total water on the earth. So in next slide, we can study various types of water demand. So the following are the various type of water demand of a town or city. So first is the domestic demand, then industrial demand, then commercial or institutional demand, then demand for public use, then fire demand. So first, why to study this type of demand? So first, the knowledge of this demand will help us for forecasting the future need, then design various hydraulic structure like dam, reservoir, canal, then for proper planning of distribution system, then for allocating the water for the particular demand based on their priority. So this is the domestic water demand. So what is meant by domestic water demand? The domestic demand, it include the water required for houses for drinking, cooking, bathing, washing of clothes and sanitary block, private vehicle and guarding. The requirement of the domestic demand animal is also included in this demand. The Indian town or city, the domestic consumption of the water under the normal condition is taken up 135 liter per day per capita as per IS 1172 to 1971. In developed countries, the water demand is very high due to their advanced lifestyle. So this is a domestic demand. So the domestic demand is the following are the subpart of the domestic demand. For a drinking purpose, the water can be used 5 liter per hour per day, drink for one person only. Then cooking 5, bathing 55, washing clothes 20, then washing toilet any other way the 10, washing cleaning houses 10, then flushing of the toilet or kitchen bathroom 30, and the total is a 135 liter per head per day. So the next demand is a industrial demand. So this demand is vary with the number and type of industrial present in the city. The ordinary per criteria consumption of industrial demand is nearly about 50 liter per hour per day on the account of industrial need. So this is a type of industry and approximate quantity of water required unit to kiloliter. So automobile industry 40, then paper and pulp industry 200 to 400, then textile industry 80 to 140, then steel 200 to 250, then commercial and institutional demand for hospitals, school, hostel, offices, colleges. This type of demand is used. The industrial demand of water depend on the type of industry in the area, the number of type of industries such as cloth, mill, paper, cotton, sugar, chemical, rolling industry. These water demand for the purpose is generally assumed 20 to 25% of the water demand of the town or city. So this is a table for a type of institutional demand. Or in institutional demand, the water is used for institutional purpose. For example, offices, hostel, hotel, cinema, hall. So this is the table for type of institute and average water consumption in liter per hour per day. So office for 45 to 90, hostel 135 to 180, hotel 180 per bed, then cinema hall and theater 15 per seat. So demand of public use. So public demand means it includes the water required for public places such as sanitary block, parking, swimming pool. The water demand for the purpose is considered 5% of the total consumption of water of town or city. So in India, these needs are not considered as important, and hence the nominal amount not exceeding 5% of the total consumption is allocated. So the next is a fire demand. So fire demand in case of any outbreak or fire in busy area of town or city, the sufficient quantity of water may not be available for fire fighting from the surface source, such as pond, open well. Again, these source may not exist within busy year of the town or city. Hence, request amount of water for firefighting should always be kept stored in underground reservoir in specified place, and fire hydrant should be established in the main pipeline at the interval of about 100 meter to 150 meter. So the quantity of water required for existing fire can be easily available. The discharge of each stream should be about 1100 liter per minute. So formula for fire demand means the water required for fire demand is calculated for following formula. First, Kitchen formula. The formula is equal to Q is equal to Q means a discharge. Q is equal to 3182 under root of P. So Q means your liter per minute. P is your population. Then Bushton formula. The formula is Q is equal to 5663 under root of P. Then Firman's formula. Q is equal to 1136 in bracket P divided by 5 plus 10 bracket complete, where F is equal to 2.8 under root of P, where F is denoted as number of simulation fire stream. Then National Board of Fire formula. The formula is quantity of water is equal to 4637 under root of P into bracket 1 minus 0.01 under root of P. So next point is a population forecasting. So population forecasting is a important method for deciding the future population to anticipate the future need from the design point of view. So following are the method of determining the population forecasting. So first method is arithmetical increasing method, then geometrical increasing method, third incremental increase method. First, arithmetical increase method. So it is the most simplest method, generally gives low result than other method. Assumption in this method, the increase in population from decade to decade is assumed constant. This method is used for forecasting the population of those large cities which have reached their saturation population. So then next, arithmetical increase method. The future population Pn after n decade is thus given by Pn is equal to P plus Ni, where P is equal to present population, N is equal to number of decade, then I is equal to average incremental for a decade. Then Pn is equal to future population at the end of the n decade. So second method is the geometric increase method. This method gives higher result since the percentage increase never remains constant, but instead decrease when the growth of city reaches to saturation. Assumption in this method, it is assumed that the percentage increase in population from decade to decade is constant. So this is the formula for the geometric increase method. Pn is equal to P under root of 1 plus Ig divided by 100 raised to n, where Ig is equal to average percentage increase per decade. Then incremental increase method. So this method is the combination of both arithmetical and geometrical increase method. So the formula for Pn is equal to P plus Ni plus n in bracket n plus 1 divided by 2 into R. So where I is equal to average increase per decade, then R is equal to average incremental increase. P means your population and Pn is equal to your future population. So depending upon this above method of population forecasting, we can solve the following type of problem. So this is the following is the population of data of a city available for past record. Determine the population in city by 2011 by arithmetical increase method, then geometrical increase method, incremental increase method, graphical method, and decrease rate of growth method. So first, incremental increase method. So this method is combination of both arithmetical and geometrical increase method. So Pn is, this is the formula actually done. This is the problem. This is the solution of population forecasting by incremental method. Then answer arithmetical increase method. The Pn, the population is 94,94800. The geometrical Pn 1,38,590. Then incremental increase 95,706. So factor affecting the rate of demand. So first factor is the size and type of community, then standard of living, then climate condition, then quantity of water, then pressure in water supply, then system of supply, then sewerage facility, then metering, then water rates, then launch sprinkling. So quantity of water as per IS 10500 in year 2012. So this is a properties of water or characteristic of water. So water can be characteristic by three methods. First physical, then chemical and biological. In physical method, there are subpoint color, taste and odor, temperature and turbidity. So first color. So in color is measured by tintometer, measure against various standard shade of platinic chloride or Hazan scale or Cobalt scale. So this is the first characteristic color. Then next taste and order. Then in taste and order is measured by Osco smoke or in terms of threshold order number. As detection is varying from person to person, these physical tests are difficult to measure. Then public water supply is greater than 3 threshold order number. So test may be due to minerals, domestic sewage or industrial waste, etc. Then next temperature. Normally during the water supply scheme, that average temperature is 10 degree to 20 degrees Celsius, should not be greater than 25 degrees Celsius. It is objectionable, or if water is the temperature of water is greater than 25 degrees Celsius, the water is not suitable for drinking purpose. Then next is the next and very important parameter of physical characteristic of water, that is the turbidity. Turbidity is a colloidal matter like silt and sand or clay impact turbidity of water. It is the expressed as a parts per million, in short ppm or mg per liter. The permissible turbidity of portable water should be 5 to 10 ppm. The turbidity can be measured turbidity rod, then Jackson turbidity meter. Then chemical properties of water. In chemical properties of water, the chemical properties are subdivided into total solid, then chloride, then hardness, then pH value, then metal and other minerals, then nitrogen and its compound, and dissolved gases. So drinking water standard as per IS 10500 in year 2012, this is a drinking water standard. This is a color and hazards and unit max. So acceptable limit is a 5 and permissible limit as per WHO, means World Health Organization, is 15. So reference is a IS code part 4. The order, then pH value is 6.5 to 8.5, taste accessible, then turbidity 1 to 5, then total dissolved solid 500 to 200. So this is the permissible limit of the some physical, chemical, and biological parameter.